3.8, number 318. Find the points where this particular curve, y cubed minus 27y equals x squared minus 90, has vertical tangents. Okay, a vertical tangent line, right? Vertical tangent line would mean that the slope is undefined. I described a while back that it really means, in some sense, the slope is infinite. But saying it's undefined is sufficient for these types of problems. We don't have to come on to the infinity concept per se for the slope. So we just want to find where the slope is undefined for this particular curve. So to do that, we need to find translates into find where the standard derivative in the plane, the standard slope in the plane for this curve is undefined. Okay, so we need to use d dx to get the derivative of this curve. And then we'll see where it doesn't exist. So apply d dx to both sides of this equation. Y cubed minus 27y. And that's equal to the derivative operator applied to x squared minus 90. All right, so when the derivative encounters this difference, it will apply itself to the y cubed first. So that's a chain rule, right? You got the power rule on the outside. You got the power rule on the outside, and you've got the function y here on the inside. Right? So you power rule. Inner function stays the same. Remember, y is a function of x in these ideas here. So, and we got to multiply by the derivative of the inner function to complete this. So that will be the symbols dy dx again. Minus. The derivative applies to this. It moves past the constant multiple and applies itself directly to the y, but that is nothing other than the symbols dy dx. This equals regular derivative on the right-hand side is 2x, and 90 goes to 0, of course, because it's a constant. All right, so there's our derivative equation. Now we just need to solve for dy dx. So these two terms, I can factor off dy dx. And we'll be left with 3y squared minus 27, it looks like. Equals 2x. So now dividing off by the factor on the left, dy dx is shown to be, for this curve, it's always 2x over 3y squared minus 27. All right, so I want to know, where is this undefined? Where does that happen? Well, clearly, wherever the denominator would be 0, right? Wherever that's equal to 0, you would have a location with an undefined slope, right? In this case, it would be an infinite slope. So let's just set this equal to 0 and solve. We have 3y squared minus 27 equal to 0. Factor off the 3. We see a difference of squares happening. This is so fortuitous, it can't be a mistake. All right, so when y equals 3 or negative 3, we'll have an undefined slope for our tangent lines, and therefore that would be a vertical tangent. Now, let's define the points where this is happening. So all I found right now is the y coordinates of these points. So let's go back and find the x coordinates. So I have to plug these back into the original back into the original equation here, if I suppose that y is 3, right, for y equals 3, the equation would read 3 cubed minus 27 times 3 equals unknown x squared minus 90. We'll have 27 minus 3 27s, of course, negative 2 27s. And that will equal x squared minus 90. So now let's see, we have a negative 54 plus 90 is what? 36. So we have 36 equals x squared. So that means x is going to equal plus or minus 6. So it turns out there's actually two x locations that provide a value of 3 for y. So this actually produced 2 points, and that is 6, 3 and negative 6, 3 are already 2 points where the tangent line is vertical for this curve. Now we do the same thing again with negative 3 for y and see what that produces for x. Y equals negative 3. We have negative 3 cubed minus 27 times negative 3 is x squared minus 90. So negative 27 plus 3 27s is 2 27s equals x squared minus 90. We have 54 added to 90 is 144. Therefore x is plus or minus 12. So again, 2 points emerge from this. 12 comma negative 3 and negative 12 comma negative 3. So it turns out there were 4 points, even though we only found 2 y values. There were 2 different x locations for each one in this particular curve because of its structure that would produce those y values. So these are 4 legitimate points on this one curve where the tangent line is going to become vertical.